What you are about to hear is not confined to the world of fiction, nor is it rooted in the nebulous sphere of internet conspiracy theories. Instead, this is a thorough reconstruction based on actual observations, verifiable calculations, and independent analyses that position Atlas as one of the most perplexing objects to traverse our solar neighborhood. In recent months, a series of high-resolution images, spectroscopic data, photometric comparisons, and cold hard facts have alerted numerous astronomers, including Avilob, who maintains that there is an aspect of Atlas that doesn't conform. The intention of this script is to lead you methodically through this enigma. We will explore visual anomalies, energetic inconsistencies, spectral signals, and the implications of various statistical coincidences. We will trace the line of hypotheses proposed by Loeb, examining why some scientists deem it premature to classify Atlas as merely another comet. You will witness calculations that scrutinize traditional explanations, comparisons that dismantle simplistic interpretations, and a thorough, organized review of the 12 anomalies identified thus far. Recent images of Atlas captured by powerful telescopes, professional observatories, and adept amateur astronomers showcase a scenario that should not exist. The initial shock lies in a jet pointing explicitly toward the Sun, the central star of our solar system, defying expected behavior from particles expelled by the combined effects of heating and solar wind. And if that weren't startling enough, an antitail is visible both before and after, maintaining its shape, spatial coherence, and brightness in a manner inconsistent with what we typically define as a perspective illusion. Natural antitails do occur, but they require specific configurations and are seldom stable enough to persist as seen in Atlas. Picture this: an object, originating from outside our system, traversing the inner region, enveloped by a jet that contradicts traditional directional expectations and a geometric structure that refuses to act like mere dust. Fine particles should disperse, pushed away by solar wind, spreading out in the opposite direction. Yet, in Atlas, these particles seem to operate under an entirely different set of rules, directional and possibly unaffected by solar radiation. A noteworthy detail among your source materials presents a potential correlation between neutrino flux variations and the recent behavior noted in Atlas. Neutrinos interact so weakly with matter they generally offer little insight into local astrophysical phenomena. However, some particle observatories have detected temporary fluctuations that align with Atlas's anomalous behaviors. While these signals do not confirm anything on their own, they are not easily dismissed. What's particularly intriguing is that such variations are more consistent with internal energetic processes, asymmetric heating, or sudden releases of volatile materials than with typical solar-driven. Traditional comet behavior leads to predictable surges in jets and the expansion of the coma, but coinciding these surges with minor neutrino fluctuations shifts the perspective, suggesting an activity profile that conventional comet physics struggles to explain. If this correlation holds even marginally, it may indicate that Atlas undergoes something more profound than mere surface-level ice sublimation. We could be observing a more intricate internal structure, with chambers or volatile pockets activating in sporadic sequences and generating energetic outputs, not detectable through conventional photometry. While it is premature to draw bold conclusions, it is equally unrealistic to pretend that no unusual phenomena are occurring. For now, discussions remain open, but one fact is undeniable. If neutrinos are involved in this narrative, even as indirect indicators, then Atlas necessitates a revised interpretative framework. Visually, it is captivating. Scientifically, it poses a significant challenge, a challenge substantial enough for many to begin suspecting that we may not be encountering a comet at all. The calculations tied to these images are not speculative musings. They consist of fundamental equations regarding energy, thermal balance, and jet dynamics. When juxtaposed with the actual images, they reveal structural inconsistencies. Atlas would need to be ejecting materials at an exceedingly high rate, necessitating a surface area far exceeding what is estimated for its core. This presents the central dilemma: to generate jets as long, bright, and columnar as has been observed, the object would have to absorb energy from the Sun at an intensity hundreds of times greater than what its surface area could feasibly allow. Even if we make generous assumptions about absorption coefficients and an optimistic assessment of its volatile composition, the calculations simply do not add up. Moreover, simultaneous jets being ejected both towards the star and away from it indicate that internal energy sources or directional mechanisms must be at play. Comets, no matter how active, do not exhibit such controlled symmetry, and solar heating does not function in this manner. Ejecting material against the thermal flow is akin to projecting cold vapor against a fire. Something must be catalyzing this action. As we compare the volume of ejected mass with the time frame available near perihelion, the discrepancies intensify. There isn't enough area, nor sufficient energy, and no straightforward natural mechanism can account for what we observe. Avi Loeb has been advocating a point that seems obvious but is often overlooked when confronted with perplexing data. The scientific endeavor should not be to defend established explanations, but rather to broaden the avenues of exploration. He highlights that the number of verified interstellar objects is astonishingly limited. Only a handful have been detected thus far, and it is an unjustified extrapolation to assume they all behave like local comets. Loeb contends that immense resources are spent searching for hypothetical particles that have yet to manifest, akin to certain dark matter candidates, yet we remain dismissive when an interstellar object is speculated to possess technological attributes. Why is this? What objective criteria justify one hypothesis being deemed less acceptable than another? In essence, questioning the established narrative is not mere speculation. It is a fundamental aspect of scientific inquiry. Dogma is indeed the obstacle, and Atlas puts this boundary to the test. Let's revisit the topic of energy, as this is where conventional explanations falter. Take, for instance, if Atlas's plume were primarily composed of carbon dioxide, the sublimation of this substance requires a specific amount of energy per unit mass. Now consider the energy the object receives from the sun. How much mass would it be ejecting? When you align these figures, you find that Atlas would be performing far more work than it should be capable of managing, akin to a flashlight powered by weak batteries, producing the illumination of a lighthouse, a scenario fundamentally contradictory to its energy source. If we substitute carbon dioxide with water, which is more challenging to sublimate, the dilemma intensifies. Adjust parameters, adopt optimistic estimates, and the outcome remains unchanged. The conventional explanation cannot account for the intensity and continuity of the jets. Importantly, we are not discussing dispersed, turbulent jets. We are referring to columnated filaments and elongated needles of matter extending across millions of kilometers, exhibiting unexpectedly uniform apparent thickness. Natural behavior does not fit within the existing model. Technological behavior is much harder to dismiss. When we consider a technological hypothesis, what could it signify in practical terms? When discussing a technological hypothesis, we are not conjuring images of radiant spacecraft akin to those in movies. We are considering the possibility of advanced civilizations deploying artifacts that drift through space for millennia. Such artifacts could naturally become encrusted with dust and ice, taking on the appearance of a comet. They could also employ propulsion mechanisms that produce visible plumes, controlling directional jets for course adjustments, housing internal heating systems that melt or sublimate accumulated materials, and displaying varied spectral signatures such as excessive nickel, or releasing small devices like probes that could be detected as unusual fragments. All of this is technically plausible within the context of advanced engineering. None of this evidence alone unequivocally proves the existence of technology. Yet, when one combines inverted jets, anomalous nickel ratios, unexplained and extreme collimation, the technological hypothesis ceases to be mere fantasy and emerges as a legitimate avenue for investigation. The notion that Atlas could be artificial elicits an emotional response from many in the astronomical community: fear, unease, and instinctive defensiveness. Accepting this possibility alters the entire discourse. We are no longer discussing an extraordinary phenomenon, but potentially the first direct indication of intelligent extraterrestrial civilization. Political and social implications also come into play. Which nation would spearhead investigations? Who would have access to the findings? How would public ramifications be managed? Would there need to be an international protocol? This is all far more daunting than merely admitting an object may possess an unusual chemical composition. Nevertheless, Loeb emphasizes that emotional or institutional discomfort should not obstruct analysis. Atlas warrants curiosity rather than immediate dismissal. The close approach to Earth represents a singular opportunity. The measurements we take now will significantly influence future interpretations. Here's an essential checklist. First, conduct high-resolution spectroscopy to ascertain the plume's velocity and composition. If abnormal metallic signatures or artificial ratios exist, we will identify them promptly. Second, investigate light polarization. This data can reveal the size, shape, and particle structure. Natural dust exhibits specific patterns, while structured bonds or processed materials present different ones. Third, monitor acceleration. If directional propulsion is at play, we will detect consistent, repeated, measurable deviations that are not. Fourth, analyze thermal signatures, as natural objects glow based on solar heating, while artifacts with internal heat exhibit distinct glowing patterns. These four components collectively form the core of our observational objectives. To avoid extremes, it is beneficial to categorize hypotheses into three primary scenarios. Scenario A suggests extreme natural anomalies, where Atlas could represent a unique composite with unusual thermal and physical properties, offering partial explanations for certain phenomena, yet struggling to clarify the collimation of the plumes. Scenario B posits a fragmented structure of considerable mass, whereby Atlas could be a cluster of aggregated objects resembling a group of fragments. This would clarify a higher apparent mass but fail to account for directional jets. Scenario C presents a technological artifact with controlled propulsion, processed materials, directional ejection, and non-natural thermal emissions anomalies that fit this model, yet necessitate a significant shift in perspective. Each scenario generates distinct predictions, and the scientific task is to evaluate these rather than dismiss them due to discomfort. Moving from common sense to concrete steps, there are 3 crucial actions for science to undertake. First, maintain coordinated observations using telescopes and spectrographs, functioning as an interconnected network that shares data in real time. Second, prioritize measurements that effectively differentiate between the hypotheses, including spectroscopy, polarimetry, and acceleration tracking. Third, devise plans for interception missions aimed at future interstellar objects. We are not discussing fiction, but advocating for scientific prudence. The stakes are high, but the potential rewards are immense. Above all, it is vital to ensure transparency regarding the data. Nothing fuels misinformation more than opaque processes. Here is the complete overview of the 12 anomalies organized clearly, directly, and didactically. Each anomaly presents tension with current models while collectively forming a disturbing dossier. First anomaly: retrograde trajectory aligned with the ecliptic. An interstellar visitor should not approach aligned with the plane of the planets, making the statistical probability quite low. Second, anomaly: jets directed toward the sun, which contradict conventional sublimation physics. Third, anomaly: an excessively high core mass, with estimates significantly above what is anticipated for interstellar travelers. Fourth, an Himalayan improbable sequence of planetary encounters that resemble a calculated trajectory rather than a random path. Fifth anomaly: an excessive nickel in the plume, a marker more aligned with industrial activity than with natural comets. Sixth anomaly: insufficient water content, an atypical behavior given the observed brightness. Seventh anomaly: a strong negative optical polarization, light responses inconsistent with standard cometary dust. Eighth anomaly: an approximate alignment with the region of the wow signal, an unlikely coincidence but statistically significant. Ninth anomaly: an abrupt spike of blue brightness, an intense hue atypical for known comets. 10th anomaly: an impossible energy balance, with jets demanding more energy than the core could possibly absorb. 11th anomaly: significant non-gravitational acceleration. Internal or directional forces appear to be in play. 12th anomaly: jets that are columnated over vast distances, a persistence unmatched by any natural model. This collection forms the crux of the mystery at hand. Disregarding it would be Atlas compels us to embrace a simple lesson: when reality deviates from explanations, the explanations must evolve, not reality. Science progresses when individuals choose to confront the strange and say, "Let's investigate." Automatic denial represents a kind of intellectual blindness, and Atlas has arrived to test our observational acuity. What we currently understand is clear. There is no singular explanation that thoroughly reconciles all the data. We are presented with discrepancies, improbable coincidences, objective anomalies, and signals that warrant rigorous examination. Should Atlas prove to be a natural entity, it would broaden our comprehension. Conversely, if it is not, we stand on the brink of the most significant scientific milestone of our time. Regardless, ignorance of it would be unforgivable. And now, I pose this question to you. What do you believe Atlas truly is? A newfound type of natural body that challenges our models, or something technological, crafted and dispatched by intelligences beyond our comprehension? Share your thoughts and hypotheses, and continue to stay tuned. The next data could potentially redefine everything we thought we understood.